video chemistry lesson. The plan is going to be, for the next couple of weeks, we're going to recap the atomic structure module and then build into the ionic bonding section of the scheme of work. For set 1, you've already done a good chunk of the ionic bonding work, but I do feel that having done that before Easter, some of you managed to access it, some of you didn't. It would benefit everyone if we went through it again. There will be some extension tasks in here to stretch you on a little bit further if you do feel you've already done it, but I think to consolidate all your understanding so far and doing the same as everyone to get everyone to the same point would be really, really beneficial. So today's lesson, we're going to have a look at the structure of the atom and the subatomic particles. We'll do an assessment task on that, a little set of questions, and then next lesson we'll go on to moving on to ionic bonding. So, start off. This is the kind of thing that we need to be able to answer. Again, none of this should be new. Hopefully you'll be familiar with all the kind of things we're going to be looking at. So the three big ideas. We're going to look at how the model of the atom has changed over the last 200 years, how parts of the atom compare with each other, and why do atoms have no overall charge. So they are our three major progress questions. So if we start off and start looking at how the model of the atom has changed. Now this is the sheet that we used in class, so you should be familiar with this. If we go right back to John Dalton's model in 1803, the way John Dalton described an atom was as a solid sphere of matter. And he understood and he thought that it could not be divided up. In that model, there was no mention of positive particles or negative particles, just a solid sphere. Moving on almost 100 years to J.J. Thomson's model, he developed the idea of the plum pudding model. And in class we talked about this being a bit like a chocolate chip cookie, whereby there's a cloud of positive charge, which would be the cookie dough, and within that are small negative particles, which we now call electrons. They would be represented in the chocolate chip cookie model by the chocolate chips. That's a model that then got developed further by Rutherford in 1911, and we call that the nuclear model. And we're starting to get to a model that's more familiar with the one that we are studying at the moment. Here we have a centrally positively charged nucleus surrounded by electrons orbiting around it. Moving further, we've got Niels Bohr's model, and this is where we stop. And this is the model that we use in school for GCSE science. So here we've got a positive nucleus. This diagram doesn't show, but within that positive nucleus there are the protons and the neutrons. Orbiting around that in shells or orbits are the electrons. And that is how the model has changed. Now that's often a 6-mark question in exam papers. This diagram, which you do have in your books, but I'll make available on today's lesson, is really good for clearing that up. Okay, so that's where we need to be for that. Now if we have a look at our understanding of the model of the atom as it is, on the screen now you can see we've got 3 particles that we need to be able to talk about. So if we start off in the middle, in the nucleus, where the mass of the atom is, there are the positively charged protons. Inside that nucleus as well, there are neutrons, and those neutrons have no charge. Orbiting around that nucleus in shells, there are negatively charged electrons. Now, models that we see on screen have limitations. Within this model, you have to visualize that those electrons are moving. So that's what this diagram is trying to show, that the electrons are constantly moving around that nucleus. But for sake of simplicity, we show it more clearly as seen in that diagram. So 3 particles that we need to know about. Protons inside the nucleus, neutrons inside the nucleus, and electrons orbiting around the outside. Now we have to know also about the properties of those particles. So if we have a look at the protons, protons have a positive charge. So in class we've remembered that because the p's have gone together. Protons have a mass of 1, Now, this is one of the few times in science where you don't use a unit. Because the mass is so small, we just refer to it as a relative mass, and that's compared to the proton, so it has a relative mass of 1. Electrons have a negative charge. As well as that, they have a negligible mass. So they have an almost unmeasurable mass. It is very, very, very light. Again, in class we talked about the way of remembering that is the electrons are whizzing, they're flying around the outside of the nucleus, so they'll need to be light. Back inside the nucleus, we have a neutron. Now, a neutron has no charge, and it has a relative mass of 1. So there are 2 particles that have a mass that are heavy, which are protons and neutrons. The electrons are the light particles. Then we have protons with a positive charge, electrons with a negative charge, and neutrons with no overall charge. Now, if we go back to our progress questions, we've looked at how the model of the atom has changed over 200 years. We've also looked at how the different parts of the atom compare with each other, so where protons, electrons and neutrons are in the atom, how heavy they are, and what charge they have. The next thing we need to have a look at is why atoms do not have an overall charge. If we look at this table, it should help us out. Protons have a positive charge. Electrons have a negative charge. Now, different atoms have different numbers of protons. If an atom has 3 protons, the nucleus would have a positive 3 charge. If atoms have no overall charge, there must be something to balance that off. So the atom must also have 3 electrons to cancel out the positive charge. So atoms have no overall charge because the number of protons is equal to the number of electrons. Now, if we have a look at these progress questions, we should be able to have a go answering these. So I'd recommend you pause the video here, grab a pen and paper, and have a go at doing these questions. They should take you 4 or 5 minutes, and then we can have a look at the answers together. So if you pause the video now and have a go at them. Okay, so looking through this, we have a lithium atom which has 3 protons, 4 neutrons and 3 electrons. We need to be able to draw a diagram of this atom. So in your response, you need to show where the protons are and how many there are, where the neutrons are and how many they are, and where the electrons are and also the number of electrons. The next part is saying why the atom is neutral. So you'll need to talk about the 2 particles which have a charge and say how their numbers relate to each other. The next thing is looking at part C, how many electrons would be in the atom if it has 17 protons. So if we have a look at the answers. Sorry, bit of a glitch here. Here we go. So the diagram should look like this. Whereas here we can see we've got 4 electrons. If we are drawing it for lithium, we would have just 3 electrons in the outer shell. We would have, 3 electrons in the shells. We would have 3 protons and we would have 4 neutrons visible. Next thing, why is the atom neutral? So if we look at the answer to B, there are the same number of protons as electrons. The positive and negative charges cancel each other out. And finally, based on that one, how many electrons would be in an atom if there were 17 protons? Well, if there were 17 protons, that's the 17 positive charges. We know we have to have 17 negative charges, which would be the 17 electrons. So that's that first lesson sort of done. On the assignment, there'll be some questions to go with that, which will give you an idea of what your understanding is of it. If any of you do fancy an extra challenge, just pause the video here and see if you can have a go at answering the extend question. For that, you might just want to type it out on a Google Doc and then submit that in to me to see how you get on. But that is quite a tough question which will really test your understanding of the subatomic particles we've discussed. Okay, I look forward to seeing you next lesson.